All right, let's talk about radians. So we know that degrees. We talked about our landmarks, right? 0, 360. So degrees are the way degrees are measured is we take a full rotation or full circle, and we divide it into 360 equal pieces, right? And each piece is a degree. All right, so that's one way to measure an angle is in degrees, and that's kind of the one that is probably most common and the one you've most likely seen before. The one you haven't seen before is radians. So radians, instead of taking a circle and dividing it into 360 pieces, what a radian does is it takes a circle of unit 1. So let me see if I can draw a good circle here. So we have a circle where the radius is 1 unit. Okay, and what a radian is it's the distance around that circle. It's the arc length of that circle to whatever point you get to where the terminal side is. Okay, so instead of dividing a circle into 360 pieces, what a radian does is it takes a full rotation, is basically the circumference of that circle, and then you see how many times you go around that circle, right? And it could be a portion of that, a fraction of the circumference, or it could be multiple circumferences, right? You could go around more than once. Okay, so let's calculate this. If I have a circle with radius 1, what would the area be? Well, we know that area of a circle is pi r squared, right? And so, or excuse me, that's the area of a circle. We know the circumference of a circle is 2 pi r, right? And so if the radius is 1, then it would just be 2 pi times 1, right? Which is just 2 pi. Okay, so the length around this whole circle here is 2 pi. All right, so we start at 0, just like with degrees, so 0 radians. And then we end up at 2 pi radians. All right, so let's kind of reverse engineer this. So if 2 pi radians is a full circle, what would be a half rotation? If I went from here to here, what would that be? Well, that would be half of 2 pi is 1 pi, right? So this would be pi radians. Okay, and then what if we went half of that? If we just went here, a right angle, well, that would be pi over 2, right? It'd be half of a pi. Okay, so basically half of a pi is a right angle. So if I go another right angle here to get here, then what I would do is I would add pi plus a half a pi is 3/2 pi, right? 3 pi over 2. Okay, and then another half would make 4 pi over 2, which is 2 pi. Okay, and then you can keep going. If you add another half a pi, you would have 5 pi over 2. And then you would get to 6 pi over 2, which would be 3 pi. And then you'd get to 7 pi over 2, and so forth. And then this would be 4 pi. And so you can continue to go around the circle just like with degrees as many times as you want. Okay, so that's what a radian is. So the easiest conversion factor for radians is we know that 1 pi radian is a half of a full rotation, right? We know that's also 180 degrees. So that's our conversion factors. Pi radians equals 180 degrees. Okay. All right. So now if I asked you to draw an angle in radians, then like let's say I said sketch the angle, let's say 7 pi over 3, or let's say 7 pi over 6. Okay, so what we do is we know that this is 0 pi over 2 pi 3 pi over 2 2 pi, right? So this is less than 2 pi, so we don't have to go past 2 pi. But what I'm going to do is I'm going to start on the terminal side, and I'm going to go counterclockwise. And 7 pi over 6 is more than 1 pi, right? More than 1 pi, less than 3/2 pi. So it's going to be somewhere in this third quadrant here. 7 pi over 6 is closer to pi than it is to 3 pi over 2, right? One way to do this is you can actually convert. You can make this 6 pi over 6, right? In other words, just make a common denominator. So 6 pi over 6 is 1 pi. This would be 3 pi over 6 if you want to do a half a pi. And then this would be, if I multiply the top and bottom by 3, it'd be 9 pi over 6. So 7 pi over 6 is closer to 6 than it is to 9. So my terminal side is going to end up being, something like that, right? And so then what's going to happen is I'm going to go from the positive x-axis counterclockwise, and that's where I'll end up. Okay, so that's how you would graph or you'd sketch radians. And there aren't any in the book or in the on the assignment, but this might be something I give you on a quiz, is to sketch a radian measure degrees. Okay, or excuse me, a radian measure angle. Now, here's another way to go. Another way to do this is to take 7 pi over 6 and convert it to degrees. And we're going to talk about how to do that later on. And then you can graph it just in degrees. All right, and we'll talk about that a little bit later. All right, so now let's talk about coterminal angles. So coterminal angles, co means together, right? And terminal means the end, where they end up, right? Terminal side. So coterminal angles are angles that end up in the same place, in the same location. All right, so like here, for example, if this is my angle, 100 degrees, and I have this terminal side right here, well, that's one way to go, right? Is just go from there to there. But I can also go all the way around and get back to here, right? So instead of being 100, that would be 360 to get to here, and then another 100, so this would be 460, right? So 460 and 100 are coterminal. And I can keep going around as many times as I want and get more coterminal angles, right? I can also go backwards. I can make a negative angle. I can go this way and get to a coterminal angle, right? So that angle would be, let's say I'll go 90, 180, and then what's the difference between 180 and 100? It'd be 80, right? So this would be 80 right here, right? If it was 100 to get this way, then it'd be 80 to get this way. So basically I went 180 plus 80, which would be 260. So this angle would be 260 right here, but it'd be negative, right? Because we went clockwise. So negative 260 is also coterminal with 100. So think about this. How many coterminal angles are there? Like how many angles are there that are coterminal with any given terminal side? And that's right. If you said an infinite amount, that's exactly right. I could do that. I could play this game forever, right? We could go around more than once and get to another one. We could go around, as many times we want to get to that next coterminal angle. Okay. All right. So basically the way you find a coterminal angle is you just go around another time. And when you go around another time, what that does is adds 360, right? Or you could subtract 360, because if you go the negative way, that would also give you a negative angle, right? So if you look at the math here, if I take 100 and add 360, that would give me 460, which is this angle that we got, right? Or if I take 100 and subtract 360, that would give me negative 260, which is this angle, right? And so that's all you have to do, is just add or subtract 360 as many times as you want, and you're going to find a coterminal angle. Okay. Now let's talk about radians. If I have a measure in radians, it would be the same thing, except for instead of 360 degrees to make a full rotation, with radians it's 2 pi, right? So we want to add or subtract 2 pi if we're talking about radians. Okay. Now radians, a lot of times you don't write the units on this one, because whenever you have pi as part of an angle measure, you assume, or it's implied, that it's radians. So this is one of those times where you actually don't have to include units for radians, unless it comes out to like a decimal and you don't see pi in there. Then I would make sure you put the units in there, and you can put RAD for radians for short. But yeah, anyway, so a lot of times you won't see the actual word radians, if as long as there's a pi in there. So pi is the actual value, right? 3.14159, etc. But it implies that we're measuring this angle in radians.